In this lecture we will be discussing on the factors affecting emissions. Now, so just recall our previous lectures. I think I have given a very exhaustive lectures on different types of fuels that we are actually using in day to day life. Then we are also we discussed biomass and then we discussed fossil fuel. Biomass, of course, there is actually lots of things that you see today that is present in the environment and which can be used as a fuel, that is called biomass fuels. It could be leaves, it could be wood, it could be agriculture waste products, or even products that we are using in the cooking and other purposes, especially the cow dungs and other things. So, those things are actually classified as what you call modern carbon. They are called as modern carbon as well, and then they are defined under the category of biomass. Now, the second category, which is mostly used, is diesel, petrol and then coal that we are actually using. Now, we have the CNGs and PNGs. In previous lectures I have discussed that what are the different compositions of these fuels that we are using, how they can be used, and what are the traces that can be used. In the coming lectures we will discuss that one. The another very important thing is, because see, this is a very important thing, that a fuel is there. So, you have some fuel, we will discuss anyway, we will discuss that how the emission factor varies, activity rates and other things in the coming slides. Okay. Okay, so this is important slide that depicts that what are the factors affecting fuel burning and emissions. So, kindly note here, the fuel burning is actually, I am not putting actually fossil fuel or biomass, any kind of fuel that you are using, and what are the factors that will be actually using. The very first thing is actually fuel type. This is very important. So, the type of fuel burnt and the emission is highly dependent on the kind of fuel that we are using. Okay. For example, if you are burning crop residue or straw or wood, it can affect the emissions, okay, compared to the fossil fuel emissions like you have coal, petrol, diesel or other things. So, fuel type is very important, and when we say fuel type, of course, here we meant fuel type means we meant by composition. Okay. So, the important thing is actually composition of fuel. This is important. Okay. So, we must know the composition of the fuel itself, and then there will be another very important thing, that is actually chemistry. It will come here, right, because we will be using whether you are having a oxygen rich environment plus oxygen, or you are having a negative oxygen. I mean, you are actually oxygen deficient here. Okay, oxygen deficient environment, and then actually you have oxygen rich. So, if you are using the same compound, if you burn in oxygen rich environment, you will get the different byproducts compared to the same if you burn in an oxygen deficient environment. So, this is very important. We have discussed these things, but I have not covered these things, and if you are very much interested, I would strongly suggest that you do, for the especially for the master's students and then PhD scholars, if they are, they must learn this topic, that how they can be used. This is really very important. How and what are the products, how will you distinguish, what will be the composition that is coming out of burning from these substances, okay, in different environments. So, this is a topic that is covered separately, and I think the MSc and PhD scholars must read some of these papers on this one. Okay. Then the second factor that affect our burning is actually weather conditions. Okay. So, weather conditions, of course, this is not applicable for fossil fuel or biomass burning. Fossil fuel like coal combustion, of course, coal combustion is slightly dependent on this one. Okay. But if you are using diesel or petrol or CNGs and PNGs plus PNG, they are not affected by this weather condition, because they are actually used inside the chambers actually. So, you have inside the chamber you have, and the supply chains is actually kind of independent of the environmental conditions that you have. So, weather conditions will not affect the emission from these things, this is very important. But if you see, for example, you have farmers, they crop residue, when the crop residue is there, what is there actually? So, we know, I think in the last lectures we discussed that if this is actually having more of moisture, if more moisture, then less efficient burning. Okay. If you have less moisture is high, then it will be less efficient, whether it is a crop residue or biomass, any kind of things that we are using. So, this is very important that we must note this one. Moisture means like it is a wet or not. So, if you have dry, if you compare this one, dry will be actually very high burning, intense burning. And we discussed in the examples that this is the case actually like rice or paddy seasons, when you burn this one. So, you have oxygen, you have moisture agricultural waste here, but if you just burn this one in like wheat season, then which is actually almost like dry, so it completely burns off. And apart from this one, I also discussed that during the summer season, this happens during June, April and June. So, the temperature is already high, so the agricultural residue can be dried very fast, and at the same time the boundary layer is high during the summer time. So, what will happen? Even emit the same amount of biofuel. Even if you use the same amount, for example, say X kilogram of straw burning you are using, and here also you are using X kilogram, what will happen? Emission from this will be less compared to this one, because this has high moisture content, and therefore, even if you are burning in the same environment condition, means you are putting in the atmospheric condition you are burning. So, oxygen supply is not efficient. So, there are the first thing I discussed here in the previous one, that how okay. So, this condition is actually like chemical environment, basically in a way you can say that it is actually like oxygen deficient. This is also called, just to give you an idea, this is also called inert condition, and this is, we will just remember we will be using some of the terms there, and this is actually oxygen rich, means it is also called oxidizing temperature environment. Okay. So, this high temperature can increase. Okay. So, this will be actually effective, and then of course, now humidity is affecting. So, humidity should be low when they are burning, this is there, and they will not burn when it is raining, because the rainwater, as we know that if it is moist biofuel, then the burning intensity will be very less. Okay. Okay. So, let us move on to the next actually. Then the third is actually combustion temperature. Okay. This is very important. If you burn the same fuel and the same composition, I mean same fuel with the same composition, if you do the combustion as a different temperature, so especially at higher temperatures, it will emit more of polyaromatic hydrocarbons compared to the lower temperature. So, this is very important again, that we should be knowing these factors, that how it is going to affect. Okay. Then the third one is actually oxygen supply. We already discussed in this one, that's oxygen supply. And if you see in the houses, if you are from the rural areas, so that the way this is actually made, there will be actually cut here. Okay. So, what will be there? There will be actually fuel, wood will be supplied from this side, and here you have actually cut. So, this cut will actually, what is for that one? It will actually allow oxygen to enter from this side, and of course, it is open, so oxygen can enter from this side as well. And then it is not only for the oxygen coming, this is actually also for the waste product that is generated, it can be actually emitted from that side. So, this is very important that when you are actually having oxygen supply, means if you are doing the combustion in an oxygen rich environment or not. Then the biomass density, I think I discussed, this is actually another very important thing. This is a physical property, I discussed about the chemical property. So, physical property, these are all actually physical property combustion temperature, weather condition, fuel type is of course chemical. Then this is a physical conditions, like you have a pressed one, or you have made a pellet of that one, or carbonizing biomass, this can improve the density and combustion efficiency. So, this is very important, and this is why sometimes different kind of fuels are mixed actually. So, I don't know if you are from the rural areas. So what the smart ladies and who do this one, they will take the cow dung and then they will use their leftover products, leftover chara, what we call it, chara, I don't know what it's called in English. So chara, they will, cow dung, what is coming actually as a waste product from the animal, and then the leftover they will mix it actually, and they will make upla. Okay, this upla is used actually. So if you just make cow dung only, this burning will be very different compared to the if you make it with the chara. So this is important. So that's how. Then the same thing is actually happening, like you are pressing this one, all the materials are, if you are actually pressurizing, so pellets are increasing different pressures, so the burning can change, the then emission can be changed in this one. Then season is important, of course. Okay, so biomass burning emissions are high in the winter season. This is typically because during the winter seasons you not only need cold season, so you need temperature, you need to increase for the room. So additional source you are putting here, additional source of air pollution, which is actually coming from here, like you are putting for room heating purposes you are using, other purposes you are already doing for the cooking, for cooking you are already using this one, but at the same time you are using for that room heating as well as outside also. In some of the places, like the people use, we call it what is called fire, we usually make this one bonfire. Sometimes they enjoy bonfire, but the villagers, they don't enjoy the bonfire, actually they every day have the bonfire. So this is a difficult concept for the urban areas, that they call it, okay, let's do bonfire, so they will burn this one, but in rural areas this is already done. And then human persons can affect, okay, and then they can be controlling the climate and emissions. Okay, so let's come to that one again. I have discussed, I think, if you are just talking about the vehicular fossil fuel emission from vehicle here, now we are, let's discuss one case like vehicular emission. Okay, what will be happening actually? So this will be very important, that what grade of fuel you are using, what is the composition, and that type of the fuel. There are different, whether it is crude or refined, there is a like crude or refined oil. So this will impact the emissions. Okay, the same thing, whether it is distillate or residual air, that is different. Okay, so from the crude oil we make different kind of product, kerosene we make, then we make petrol, then we make diesel, and then finally even in the petrol you have different kind of petrols. Okay, in diesels you have different kind of, so that depends on the I discussed in that the additional things that are added there, which enhances the emissions or combustion efficiency. Okay, then you have here vehicular features. So weight, type, technology and driving conditions, they all are effectively affecting the consumption, fuel consumption and emission. For example, type, when we say we are actually like India is having like BS6 now, so India is actually like BS6 norms currently we are following. So BS6 norms has set a guideline that what should be minimum emission or what should be the maximum emission. So there is a guideline for that one, and whenever this is changed, the idea is to reduce the emission. So the emission factors, always we have to reduce this one. Okay, so this is actually like yeah. For example, if you are having a vehicle, heavier vehicle, so heavier vehicle, for the moving the heavier vehicle you need more energy. Okay, so this means, and then you have a high roller resistance as well, so this means you have need higher energy. When you need higher energy, then fuel consumption here will be high. So, okay, so high fuel consumption here. Then of course driving conditions, number of trips, distance travelled, driving mode. This is very important, whether you are doing in the eco mode or in normal mode, or you are putting the engine in the ideal condition or not. For example, sometimes at the when you are driving, you are at a signal. So you put the vehicle in the idle condition, so this can change. The speed can affect acceleration, and then how frequently you are doing the acceleration, that is also very important. You know, in India we used to show that okay, he is very rough driving. So rough driving means he is not only over speeding, he is actually taking brakes number of times and then accelerator off and on very frequently, so that actually, and then engine load, they can all affect the emissions. Okay, we will discuss this one. Fuel consumption rate, this is very important, because the rate of the chemical reaction between fuel and oxygen. So basically the energy that is produced is actually because between the fuel and oxygen. So the rate of this chemical reaction can affect your fuel consumption. Okay, and then oxygen is supplied similarly. So this means basically the oxygen content, how much oxygen you are supplying. And then you have IS content. This is usually very less, especially in the kind of fossil fuel, but in the biomass burning you have very high IS content. Okay, so let's discuss. This is very scientific and very important equation that we will discuss. So there is a term that is called emission factor. This is representative value that attempts to relate the quantity of fuel released to the atmosphere with an activity associated with the release of that pollutants. So here this is very important, that what is the activity that we are doing. Okay, and activity can be very different. You know, you could be burning a solid biofuel or using a petrol or diesel, then the activity rate will be different. So the emission factor is essentially mass of the emission emitted per unit activity. This is very important. Okay, so if you just do the calculation that what will be the total emission that will be coming from these things, so you can calculate E is equals to A into EF into 1 minus ER upon 100, and here ER is actually, because what will happen. So from this one, if you just see here, if you are performing, energy is actually emission is actually proportional to the what you call activity rate. So if you are performing any activity and if you are doing at a faster rate, the emission will be higher. Then the second important thing is the emission factors. So if the emission factor, because the emission factor we discussed, that is the mass of the pollutant that is emitted per unit activity or per unit of the biofuel that you are actually used. So this, if you increase this fossil fuel, emission factor. So if the emission factor is high, then emissions will be high. There is one negative point here. ER is actually like, you know, overall emission reduction efficiency. So ER is actually emission reduction. So when you have if there are some technologies in which what will happen, they will put some kind of, you know, they will within the engine, for example, they will use some catalyst, for example, they are using, so that the reaction rate can be faster. Okay, or the fuel that is actually using that kind of things are, so this will be very important, that technological advantage. So many of the civil engineering people, they do this kind of things, that how automobile engineering, they will do this one. So but for just to understand, for our idea, for our purpose, it is only important that okay, how the emission is varying. So emission, as we see that emission is actually directly proportional to the activity rate and emission factor, but it is negatively related with the emission rate. So this means if you have high emission rate, okay, emission reduction efficiency. So if you have high emission reduction, this means what it will be, actually 1 minus ER but divided by 100, this will be actually less than 1. So if you increase this ER, what will this factor is going to be reduced, this is going to be further reduced than 1. So this will be actually, when you multiply, this emission will be lower. So this is very important. Okay, so you must know the units. We will be discussing in the next slide that emissions actually, like, you know, emission factor is usually, for example, is, you know, I think I have slides so that I can, yeah, it's there in that one. Okay, so for example, emission factors is usually like, you know, for the solid fuel it will be actually gram per kilogram, I mean both the unit. of fuel it is, okay, and this gram of this will be of pollutant that is emitted. Pollutant, gram of pollutant emitted per kg of the fuel that is consumed. This is one thing. Then total emission of course will be, this unit will be actually teragram or petagram. I mean, like it will be unit of the weight or mass. Actually you can say that how much mass is emitted. Activity rate is defined again, that whether you are actually how much fuel you are using. Now fuel you can use in the, if you are using the solid fuel then actually it will be kg. If you are using a liquid fuel then the emissions here will be actually like gram per liter of the fuel that is consumed. So that it has to cancel out, because what will happen, the equation says here that the important thing is that the unit should be in such a way that if the emission factor is actually microgram per gram for example, then your actually activity should be given in the gram or per or kilogram, okay. And then of course emission reduction efficiency, this is a factor, it is a unitless factor, so this will not be counted. So the emission will be actually in gram. So you can this will be one will be cancelled out in a way, although unit cannot be cancelled, but yeah, so you can just cancel out and then you have emission in the unit of gram or teragram, sorry. So these factors is, facilitate, if your knowledge of these factors facilitate emission from the various sources of the air pollution. Now there are what are, so suppose we have to reduce that, okay, let us discuss this one, then we will discuss, okay. So emission actually, for example, so emission is actually like what you call total quantity of the emission generated. This is often expressed unit like tons or kilograms of the pollutants, or teragram or petagram, okay. This is the final output of the equation after accounting for the activity rate, emission factor and any reduction received. This in the previous equations we have. Activity rate or A is actually amount of activity or process generating emissions. So what are the process that you are actually using? For example, if you are using vehicle distance traveled by the vehicle, so we will use actually vehicle mile traveled, or we use actually simply VKT, vehicle kilometer traveled. So how much kilometer will be traveled actually? If you are actually you are putting this one, for example activity rate, this means the distance will be actually like kilometer. Now so here if you are using this in the kilometer, then what will be the unit of emission factor? It has to be gram per liter of fuel that is actually you are consuming. So gram of pollutant that is emitted per liter or per kilometer, okay, per kilometer. So you have to see that how much mile. This is also you can say in a way that if your vehicle is very good condition, so it will emit less pollutants, despite that it will be traveling larger distances. So it is traveling larger distances, but still it is emitting a less pollutant. So this is very important. So the emission, and then for example the other equations could be here like quantity of the fuel that is consumed, liter, okay, and then number of industrial processes that are performed. So you can just see that one actually that is coming into picture. Emission factor is the coefficient that quantifies emissions per unit of activity, okay. So this is how much of pollutant is released per unit of activity rate. So for example per grams of carbon dioxide per kilometer driven or per liter of the fuel burned. So if this you have to be very careful when you are calculating these things. You have to see that what is the respective unit that activity rate is using. So accordingly you have to remember, you have to convert your emission factor in that unit, so that you can calculate. Then the last one is actually emission reductions efficiency. Often it is written in the percentage, and it refers to the effectiveness of measures to reduce emissions. This is very important. So what are the factors, what are the measures that has been taken to reduce the emission, okay. The measures might include technologies like scrubber, for example in the industries, filters or catalytic converter, or policy driven like caps on the emission. This is very important. Another thing that is very important, emission reduction efficiency is like you discuss some policy which can lead to the emission. For example, if the vehicle is polluting more than say X gram per kg, then I will not be allowing x could be anything. If it is polluting more than x gram per kilogram, then I will not allow your vehicle to be traveling in that one. So now see the equation, some how this equation works. Let us see this one. Okay, this first thing is actually like A into EF is activity rate into EF. For example, suppose a vehicle is traveling 100 kilometers, so here A is actually 100. Now it is very important to note the unit. So you are putting A is equals to 100 kilometer. Okay, and it is emitting 200 kilogram of carbon dioxide per kilometer. So this means emission factor is already given 200 gram per kilometer. So the total emission would be 100 kilometer into 200 kilometer, 200 gram per kilometer. So this will be actually like 20,000 gram or 20 kilogram of CO2 that is emitted. Okay, so this is the total. So if the vehicle is traveling 100 kilometers, it will be emitting almost like 20 kilogram of CO2. Similarly, you can calculate that how much other pollutants like black carbon and carbonaceous species are emitted. 1 minus ER becomes very important, because then you have to always see the equation. It is not only ER upon 100, you have to see this 1 minus ER upon 100. So for example, this term adjust for the percentage of emission that is reduced due to emission mitigation processes. For instances, if the reduction is actually by 15%, then ER will be 50, and in that case 1 minus ER by 100 will be actually like 50. So if you just do the final calculations, A into EF multiplied by reduction factor, which is 1 minus ER by 100, so it will be like you will be having like 10,000 grams or 10 kilogram of CO2. So this is the very important. Okay, so effectively if we have to reduce this one, what can be done? This is a typical examples that is given from the different fuels that we are using here. You see here carbon monoxide, SO2, hydrocarbons, NOx and CO emissions per kg of the fuel that are actually used from the passenger car. This is for the passenger car. Okay, now you see here, if you just compare between petrol, diesel and natural gas, what will be happening here? Petrol is actually like emitting CO2. Almost petrol and diesel, they are emitting almost like of the same order, but if it is a natural gas, the emission is less. So in terms of CO2 emissions, natural gas emissions for natural gas, use of natural gas is better here. Okay, so if it is the question, for example, if the question is asked to you that this is the emission factors, discuss which one is actually more effective and should be used for the to have lower pollution levels. Then you have SO2. So SO2 is for example 0.094, again 0.095. So here they are almost like same. So same, but here actually it is very low. So again natural gas outperforms petrol and diesel activity burning. Then hydrocarbons, you see here petrol is emitting less hydrocarbons compared to the diesel. So diesel is putting more. So that's why you see that we say when in terms of hydrocarbons, we often say that diesel vehicles are giving more of hydrocarbons or unburnt hydrocarbons. They are putting more actually in the atmosphere, and CNG again natural gas again outperforms here. So now this is another very important thing that we are actually having. Then carbon monoxide, it is like actually petrol is actually 152, it is 4, and this is actually 10.4. Now see the difference. You remember what were the byproducts? Carbon dioxide, SO2, hydrocarbons, CO2 and NOx. Here you see petrol is giving more of the pollution of carbon monoxide, and we know carbon monoxide is highly kind of pollutant gas, and if you inhale you can actually become like sick. This can bind with your bloods. So this is actually because most of the time in the urban areas you see high level of CO. So this concentration is coming of because of the car, because in the urban areas many people use petrol vehicles compared to the diesel vehicles and CNG. It is often said that because they are urban areas, the car they use, they say that it is less maintenance is needed for them. okay, less maintenance. So means you have to spend less money, but at the same time, what is the more, you are giving more pollution to the atmosphere, we are polluting more, we are giving health sickness to more people if we are using the petrol cars. And NOx, again NOx is again petrol cars again is giving high concentration compared to diesel and natural gas. Again, if you see the natural gas here, diesel is actually giving less emissions. Now this is becoming actually a different terminology. If you have to calculate, for example, if you have been asked a question that this is the data sheet that has been given, now discuss your opinion that which kind of fuel driven vehicle should be promoted, and then you describe your reasoning for that one. This is a very very question. So any policy makers or policy decision makings, if you are giving the exams for civil services, this could be one of the questions concerning the air pollution, high air pollutions in the India that we are having. We have already discussed this one, and because of the paucity of the time, we are actually like how to reduce this one. You can use selective catalytic reductions, you have used diesel filters, then you can use exhaust gas recirculation. So this can reduce the emissions. Okay, where these equations can be actualized, this equation is mostly utilized in the environmental modeling, and then existing, for example, not only greenhouse gases, there is actually idea of this is emission inventory. So emission inventory is use this equation. This is a very simple equation, but there you need to know so many factors affecting this one. So you can use that one. Then estimating greenhouse gases emissions you can calculate. Then if you want to see measuring the impact of emission control technologies, you have to see, finally you have to calculate that how much emissions actually are coming, and then evaluating the effectiveness of the environmental policies. So again, this will be, if your policies can be good, can be called good if it is actually emitting less emissions, it is giving less emissions. If it is putting more emissions, then it is actually like not good. So thank you very much for these lectures. I hope this lecture is very clear. The advice would be that you should take some examples. Maybe I'll put some questions, some assignments on this one, are related topics, materials that can be studied, so that you can study and you can use this one. So practicing this is very important. So just keep practicing and writing some equations, calculating these things, so that will help you. So thank you so much. See you in the next lecture. Bye bye.